right, so density. Density is not how big an object is. It's not how heavy the object is, but it's a combination. It's a combination of mass and volume in a ratio, mass to volume. So mathematically, that is a formula. You could actually calculate the mass, calculate the volume, and divide and get the density of that object. Do you know what the density of water is?
2.2.
No, easier number. 1. Density of water is 1. Of course, we would need a unit. 1 what? 1. All right, a mass per volume. 1 gram per milliliter. So an itty-bitty milliliter in our graduated cylinder simply has a mass of a gram. Now, as far as the particles are concerned, talking about water, density is basically referring to how tightly packed those particles are. So let's say I have object A, object B. They both take up this exact same size, both these little boxes. So what is the same, their mass or their volume? Their volume. I'm trying to indicate they're the same volume. But they must have different mass. Or at least I'm trying to indicate they have different mass. So if that's the case, the more dense object would have to be A, because it has more mass per the same amount of volume. All right, A and B now, I'm trying to indicate by the number of particles. And maybe this is aluminum and then maybe heated up aluminum. They're the same mass, but different volumes. This one's more spread out. Maybe this is a liquid version of this solid, which would be true for pretty much anything but water. So what's more dense, A or B? B. All right, the million-dollar question. Look at this last picture. What's more dense, A or B?
Neither.
Who says A? Who says B? Who says neither? Or equal? Good. They are equal. Yes, A is the bigger chunk. But if that was a bar of gold and you cut off a little section of the gold, it's still gold. A is gold, B is gold. It still has the same density. The particles are still packed the same. Okay, density of water is 1 gram per milliliter, like we said. Remember that a milliliter and a centimeter cubed are the same dimension. Typically, though, we use milliliters for liquid things, centimeters cubed for something that's solid. But it's the same amount. So mentioning if something will float or sink or not in water, you would just have to compare that thing's density to the number 1. If it's more dense than 1, is it going to sink or float? Sink. If it's less than water, what's... If it's less than 1, it will be less dense than water. It'll float. All right, I'm not going to pass out the calculators. You tell me how to do these two problems. I have a few for you to do later. All right, a block of lead. Just using your common sense, lead going to float or sink? Okay, lead's going to sink. A block of lead has a mass of 200 grams and a volume of 17.7 centimeters cubed. What is its density?
200.
Good. Divide. Mass divided by volume. Just simply make sure you don't divide backwards. So we get 11.3. And at this point, I am going to sort of let the sig figs go. Of course, this will be an issue like, is it really just one sig fig? But don't tell Miss Gilstrap. You'll see sig figs again when you get into honors chemistry. Your honors chemistry teacher. But I don't want you to miss the point of the problem by worrying about sig figs. But so we've touched it. We will not really stress about it anymore. So you already told me it's going to sink. Shh. All right, another example. A block of wax has a volume of 50 centimeters cubed and a mass of 43.5 grams. Probably going to float because wax will. But what do you divide? What goes in the calculator first?
43.5
Divided by 50.
Thank you. 0.87. So we do have a decimal answer here, which is clearly less than 1. Yeah, that should be really centimeter cubed. Again, please remember the centimeter cubed, that is just a unit. You know, it's a centimeter by a centimeter by a centimeter. Imagine an itty-bitty little box. That does not mean cubed is 17.7. It's just the unit. All right, and so of course this will float. Okay, good? Good. But I do want to do number 1 and number 3, since they are asking you for things other than density. We've done a few, find the density, find the density, find the density. We're good at that. We know it's mass divided by volume. But what if I want to use the density equation and not find density? All right. So Lexi, first question. What is the question asking for?
The mass.
Good. Number 1's asking for the mass. So mass is your unknown. And sometimes it's nice to just kind of list what you know and what you don't know, what you want. So mass is unknown. And now, I haven't even read the problem, but I can pretty much figure out what the other numbers must mean by looking at the units, also with just a little bit of reading. But Kara, here's the first number I see. I got 0.92 grams per centimeter cubed. What must that be? Kara. 0.92 grams per centimeter cubed is what thing? Is it the density, the mass, or the volume? Your name is not Kara. Okay.
It's obvious though.
I know. Okay, good. Is the density? All right. Hannah, our other number, which is a million centimeter cubed, would be what? That would be the volume. And I won't try to trip you up here, but in the future I may change the units. When you do math problems, you really need to make sure the units match. You know, I can't say that 5 feet plus 2 inches is 7 meters. Can't just do 5 plus 2 like that. Units would have to match. But in this case, you know, I've got centimeters cubed, centimeters cubed. This is okay. And clearly my answer, Shandini, would be in what unit for mass? Grams. Based on what I'm given here, my unit for my answer would be grams. All right, so now we just set it up. Plug in what you know, so 0.92 equals m over a million. And James, what do I do? Good. We like having fractions on each side. Put it over 1, cross multiply. You can try to do that without a calculator. You just need 6 decimal slides there. You got 6 zeros. So our answer is 920,000, and Shandine told me grams. All right, perfect. Last question real quick. Noah, and you probably know this anyway because it's ice, but would this thing sink or float? Good, and please answer that for all of these. Just put maybe a little S or an F off to the side. But 0.92 is less than 1, so that's going to float in water. Very good. All right, I'm going to skip number 2 since that's saying what is the density. Done plenty of those. But I am going to do number 3, Taylor. Here's your question word, here's your what. What are we looking for in number 3? Looking for the volume. So volume is unknown. I should know the other things. Emily, without really even reading, what's 13.6 grams per milliliter got to be? The density. Any guesses why this one was in milliliters, but this one was in centimeters cubed?
Mercury.
Yeah, because it's mercury, it's a liquid. We usually would use milliliters for liquid, centimeters cubed for solids, but they are equivalent. All right. And Lizzie, that would mean our 155G would have to be the what?
No, that's
Good. And it doesn't even say mass. It says what's the volume of 155 gram samples. So you have got to know that grams is our unit for mass. Okay. Units are okay. Not trying to trick you there. Plug it into our density formula. All right, this is going to be a two-stepper, I guess. Eric, what should I do?
You should turn 13.6 to a fraction.
Okay, I can put 13.6 over 1. I can cross multiply. So that's just going to move the V up next to the 13.6. So now I have this line in green. So I'm not done. So Mason.
All right, you got to do 13.6 over 1, and then on the right side.
We've already done that.
You divide. Oh, yeah. Okay, so you do 13.6 V.
Yep.
155.
Yep.
And then you do 155 divided by 13.6.
Good. You want to get the V alone? So since we're currently multiplying by 13.6, we got to divide both sides by 13.6.
What did I say? That's what you did.
That's what you do.
oh.
Okay.
Yeah.
So 155 divided by 13.6. Anybody have that answer?
11.9.
11.3.
All right, 11.4. Sounds good. And Sarah, what unit would we stick on that?
Grams over.
Careful, that was already our density unit. We're finding the volume. What's a volume unit? That makes sense in this problem.
Milliliters.
Good, milliliters. That was our volume unit. So our answer's got to end up in milliliters.
Why is the L just capitalized?
It is. I don't know, just it.
You're like,
Because it's a main unit.
I don't know what lowercase l will be. Like lowercase t is time, capital T is temperature. I don't know. There's just certain rules for certain variables. Oh, and Jordan, last question. This is mercury. Is this going to sink or float in water? Yeah, it's definitely going to sink. This is pretty dense. All right, ta-da. Last class we did the density lab. You should have finished the vast majority of those measurements. If you're missing a couple items, that's okay. If you forgot to calculate the density, that's something you're going to need to remember to do on your own. Mass divided by volume for all of those objects I asked you to find the density for. I also want you to do all of the questions. I'm just going to go over a few of them with you. And you may see a few of these again on your quiz next class. So, number 6, and I'm going to use the cards, so please don't shout out. Bailey, this one's back to you. Which do you think has a greater density, a large copper ring or a small copper ring?
Quit.
Shh. Casey, stop.
sorry, I was just looking at it.
The more.
Because it's bigger, heavier? It is bigger and it is heavier.
They would both have the same one.
But they both have the same. Very good. The density would be the same. Shh. Now he's correct. The mass is different. The volume's different. But the ratio of mass divided by volume is the same. And why? Well, because copper is copper is copper. It doesn't matter how big a chunk of copper I have. The atoms are all packed equally close in any chunk of copper. So I'm going to say atoms have the same spacing, no matter what size chunk piece of copper I use or compare.
Can we write this down?
I would.
Okay.
Like I said, I'm not doing all the questions, but I kind of like to hit on these. I think these are important. Make sure we understand density. You guys need to make sure you, for homework, before we turn in our lab notebooks, finish the others. Alexa, number 7. What do you think here? Which would have a greater density, a copper strip or a wood strip of exactly the same size?
I think the copper strip.
Correct. Why do you think that?
I think the copper strip would be heavier.
Very good. If they have the same size and it's mass divided by volume, well, in that case, if you're taking out volume as a factor, the mass would win out, and that would be more dense. That ratio mass divided by volume will be greater for the copper. Also, the atoms must be more tightly packed in copper. Also, you can probably think about what would sink and what would float. Metal is more likely to sink than wood. But I'm going to go with the original answer there. Has more mass per volume. Same volume, but has more mass. All right, Abby, number 8. Which would have a greater density, water or log floating on the water?
Water.
Clearly the water. Why?
Because the water has more mass. How do you?
Well, it has more mass per volume. Yeah, if you want to say the ratio, water would have more mass per same amount of volume. But what do we simply know about floating things?
Yeah, they're less dense than water.
They're less dense, so
Because they have to slow against the water.
you don't have to write what I wrote in parentheses there. We know it's less than 1. Yeah. That is a good question. Have you ever been swimming and just simply like exhaled?
Yeah.
What happens to your body? Yeah, you stink. So if you consider all of your mass and all of your volume, including the oxygen in your lungs, the mass of that, yeah, it differs. It would be less than 1 because we do float in water. But if you exhale, then it's greater than 1. So you can actually change your own density just by how much air you have in your lungs. Sort of how submarines work too. Are submarines like taking in water to become more dense and sort of sink? Or are they expelling water to change their density? They have air. They can't stay down there forever though.
Yeah, that's what I mean, like,
There's only so much air, that's true. All right, and my last one I want to go over here is VOC number 9. A steelworker melts down steel to mold it into a beam. Which would have greater density, the solid steel or the liquid steel?
It'd be the same.
Is it the same? It is all steel. Is this the same as the copper question?
No.
What do you know about solids and liquids, though, and the particle spacing? Which would have the particles closer together? Solid, liquid, or gas? Solid. So if we go back to that idea of which one has more tightly packed particles, it's got to be a solid. Solid is more dense. And I'll put closer together. Because we know that about solids. Now, what is the exception to that rule? Ice. Ice actually, the molecules in water form sort of a geometric pattern that is less dense than water. They're more spread out. And one more thing I want to show you while we finish up density is just this density column of a bunch of different liquids and a little bit of food coloring. Any guesses as to what's on the bottom that's probably pretty dense? Yeah, I've got honey and regular syrup. It was pretty dense. They're also, a word we'll learn in this unit, they're also really viscous, which means if you were to pour them, they'd pour slowly. They're thick, slow moving, slow as molasses. Then what do we have?
So, what's blood?
Dish soap?
Yeah. We do have dish soap in here, which is mixing a little bit with the water I had. So we had dish soap, water. How about this one?
Oil.
Good, this is just vegetable oil. And we use some food coloring here, but alcohol is even less dense than that. Now I do have to have these certain layers. If I remove the oil, what would happen to the water and the alcohol? It would mix. And even the syrup and the honey would probably mix over enough time, but for the time being we have this density column.